Asphalt in Hot and Cold Conditions by Craig Ambler, Ben Delorme, and John Stevens. This presentation focuses on the differences between working with asphalt in hot and cold conditions. There are three main categories: paving practices, mix design, and maintenance. When talking about paving practices, there are three main things that change with the temperature: lift thickness, base temperature, and mix delivery temperature. These are because colder asphalt is more difficult to compact, and if it's too hot, the asphalt will flow too easily. Lift thickness is important in asphalt, especially in cold weather. This is because the colder air cools the asphalt to a point where it can no longer be compacted effectively. Lift thickness is not as important in hot weather, as the temperature difference between the asphalt mat and the air is lesser, and so the rate of cooling is slower. This is a graph showing the effect of layer thickness and cooling time on mix temperature. As you can see from the graph, it takes a minimal amount of extra asphalt to significantly increase the time available for compaction. Thickness is not always a good thing, however, as a layer that is too thick can be affected negatively in terms of compaction. This is a graph showing percent lab density versus T over NMAS, which is the ratio of thickness to nominal maximum aggregate size. As the graph shows, there is a peak density achieved at about a ratio of 4.5. Any greater or lower than that, and compaction is negatively affected, and you cannot get the same density that you would with a different layer thickness. Base temperature is also important when considering paving practices. A colder base will cool your mix faster and allow less time for compaction. This table shows the effect of different base temperatures on different layer thicknesses. As you can see, in each case, the time available for compaction is reduced by about a quarter. Base temperature is hard to control. There are things that can be done, but they are both expensive and time-consuming. The Federal Highway Administration recommends not paving below certain temperatures based on your layer thickness. The temperature of the mix upon delivery to the worksite is also important. The hotter the mix is, the longer it will take to cool. However, each binder has a specific range of temperatures within which it is workable. If the asphalt is too hot, then it will flow too easily and not hold its shape. If it's too cold, the asphalt will become unworkable and therefore cannot be placed properly with sufficient compaction. Care must be taken to choose a binder that is suitable for the conditions expected.
Now we will talk about mix designs for hot and cold weather. The SuperPave mix design system uses performance-grade binders. These binders help contractors decide on properties of their differing projects. There are a range of temperatures offered to choose from for these binders. Using this system, there is a higher initial cost, but in the long run, the lifetime of the project is increased. Also, there are less maintenance costs required due to the failure resistance provided by the system. Performance-grade binders in the SuperPave mix design system. These binders help contractors decide on specific properties for their differing projects. Ranges of properties are offered to choose from. There is a higher initial cost using this system, but in the long run, the lifetime of the project is increased. Also, there is less maintenance required due to the failure resistance that is provided by the SuperPave system. A study using organic-based additives was performed. These compounds include magnesium, manganese, and zinc, and was added at a weight ratio of 3%. These compounds were added directly to the binder itself. Testing was performed on these organic-based additives. In cold temperatures, the low temperature cracking resistance was increased by 15 to 40%. In warmer temperatures, the resistance to rutting was also increased. Additional testing was performed to ensure these additives met the mechanical property requirements such as the Marshall testing, stability, and air void tests. It was also found that these organic-based additives reduce mixing temperatures, which could possibly reduce energy costs in production of the asphalt. Aggregate blends in an asphalt mix design can also have a major effect in hot and cold conditions. When there is a high percentage of fine materials, it can lead to a stiffer mix. This stiffer mix can be more susceptible to cracking in lower temperatures. The optimum amount of air voids in an asphalt mix is 3 to 4%. This will result in stone-to-stone contact where the aggregate can support itself with the other stones. This will help reduce rutting in higher temperatures. Aggregate toughness is also important in an asphalt mix. Toughness can be tested using the LA abrasion test. If there are breakdowns during compaction, it can lead to changes in the aggregate blends.
Now we'll talk about maintenance as it pertains to hot and cold climates. Maintenance is an essential part of the lifespan of a paved asphalt surface. There are three main types of maintenance: preventative, corrective, and emergency. Preventative being maintenance that takes place before degradation has occurred. Corrective is a planned maintenance to take care of a known issue such as cracking. Emergency maintenance must be done immediately because it is affecting the use of the roadway. Original construction condition is incredibly important when it comes to the maintenance that will be needed on a road during its lifespan. Hot and cold weather contribute significantly to the degradation of paved asphalt surfaces. Winter months can be highly damaging to asphalt pavement. The conditions that create this damaging effect are often referred to as freeze-thaw conditions. Two major problems resulting from this are frost heave and thaw weakening. Frost heave occurs when the moisture in the road base or the soil freezes and expands. This causes a stress in the pavement by pushing it upwards. Problem here lies in frost-susceptible soils or in the subgrade material. As you can see from this diagram, ice forms underneath the roadway, pushing it up, causing longitudinal cracking. There are several ways to ensure that frost heave does not become an issue, or if it is, to perform maintenance and repair the road. First of these being to ensure proper design. This is done by ensuring that there are no fine-grained soils in the base material and that fine grains are minimized in the soil underneath the roadway. The second is to provide proper drainage channels that allow for any moisture that does build up in these materials to drain. As far as corrective and emergency maintenance, a patch of cracks can be completed with asphalt patcher, or cold mix asphalt can be used for larger cracks, and this is especially good for emergency maintenance during winter months, although it would need to be redone when the roadway warms up. Thaw weakening is the second major problem presented in cold weather conditions. Thaw weakening happens in the spring as the ground heats up and ice that is formed underneath the roadway begins to melt. This in turn saturates the soil and base materials, causing it to weaken. This causes the pavement to overly deflect, causing strain in the pavement, much like frost heave. As you can see from the diagram shown, the pavement deflects less in the winter, peaking after the spring thaw during thaw weakening. Hot weather can also present maintenance issues for asphalt pavement. This is mostly due to the viscosity changes that happen with an increase in temperature. The most common problems are bleeding and rutting. Where bleeding is an excess of asphalt binder that fills up the voids between the aggregate and pools on top of the pavement. This is shown in the figure in the slide. Rutting occurs when ruts are left by constant loading in wheel tracks. When constructing asphalt pavement surfaces, one must be mindful of paving practices, mixed design, and maintenance, with keeping in mind the expected weather conditions in the area they are being constructed. We will now open the floor if you have any questions.